Wassce 2025 Core Mathematics, Paper 2, Question 9. A telecommunication mast and a pillar stand on the same horizontal level. So we have our horizontal level, and on this horizontal level, we have a telecommunication mast as well as a pillar. It is obvious that the mast is taller than the pillar. Again, the mast as well as the pillar will always meet the level ground at an angle of 90 degrees. So there's our 90 degrees angle. So we are done with the first statement. Now from the midpoint O, so the midpoint O, remember the midpoint O is between the foot of the pillar S. So there is the foot of the pillar. So the foot of the pillar is labeled as S, and the foot of the mast. So this is the foot of the mast labeled as T. So this is the foot of the pillar S. We also have the foot of the mast T. We are going to measure the angle of elevation of the top of the mast. So this is the top of the mast labeled as G. It's given as 70 degrees. So from the midpoint O, when we measure the angle of elevation from the top of the mast G, that should be 70 degrees. So let's do that. We know that the angle of elevation is the angle above the horizontal line of sight. So there is the horizontal level. So any angle above the horizontal level is the angle of elevation. So we are measuring the angle of elevation from the top of the mast. Remember, the top of the mast was given as G. And again, the angle of elevation from the top of the mast measures 70 degrees. This has been done. So we are done with the second part. Also from point O, that is the midpoint, the angle of elevation of the top of the pillar. So there is the top of the pillar. The top of the pillar has been given as H. The angle of elevation is 28 degrees. So this angle here, that is the angle of elevation, measures 28 degrees from the top of the pillar labeled as H. So we are almost done. Now remember, we are told that the pillar measures 10 meters high. So the height of the pillar, that is line SH, measures 10 meters. So we have also done that. So A says we should represent the information on the diagram. That is what we have already done. Now B. So the B has two parts, I and then II. So the I part says we should measure the height of the mast. So there is the height of the mast. So we could see that we have two right angle triangles. So there is one right angle triangle. We also have another right angle triangle. So from the bigger right angle triangle, that is where we can find the height of the mast. So to calculate the height of line GT, then it means that we need the dimensions of one of the remaining sides. We need the dimensions of one of the remaining sides. So how do we do that? Remember that the distance from the point T to the point O is the same as the distance from point O to S. Because O is the midpoint, that is, it is located halfway between the foot of the mast and the foot of the pillar. It means that the distance from T to O and the distance from O to S will always be the same. So I am naming the distance from T to O as D, and then distance from O to S also as D, because they will always have the same measure. So once we know the measure of D, we should be able to calculate for the height of the mast. So now let's focus on this smaller right angle triangle. So how do we name this right angle triangle? So from triangle, I'm naming it as triangle SOH. SOH. Because it's a right angle triangle, we can name the sides. The side facing the 28 degrees, this side, will always be the opposite. So this side is the opposite. The side facing the 90 degrees angle will be the hypotenuse. That is the longest side. And then the remaining side here, that is line OS, will be the adjacent. So from this right angle triangle, we are looking for D, which is the adjacent. And then we know the length of the opposite. So let's refer from SOHCAHTOA. 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 Which of them has opposite and adjacent? Opposite and adjacent, that is TOA. Opposite and adjacent, TOA. So, and then TOA says that the tan of the acute angle. So the acute angle in triangle SOH is 28 degrees. So tan 28 is equal to the length of the opposite. So line SH, that is 10 meters, divided by the length of the adjacent, which is D. So let's solve for this. So to solve for D, we know that tan 28 is the same as tan 28 on 1. We can cross multiply. Tan 28 multiplied by D, we have D tan 28, and then 1 multiplied by 10, we have 10. We are looking for D, so we divide both sides by tan 28. We divide here by tan 28. See that tan 28 will cancel out, leaving D as 10 on tan 28. So on the calculator, let's see. 10 on tan 28. 4 decimal places, 18.8073. 18.8073. 8073. That is to 4 decimal places. So D is length, so in meters. But remember, we are not looking for D. We are looking for the height of the mass, which is line GT. So to calculate that, we need to refer from the bigger right angle triangle. So that is from triangle. So I'm naming the bigger right angle triangle as triangle TOG. Triangle TOG. So from triangle TOG, we know that the side facing the acute angle will always be the opposite. So this is the opposite. The longer side will be the hypotenuse, and then the remaining side will be the adjacent. So from this right angle triangle, we are looking for the opposite, but we know the length of the adjacent. So again, when we refer from SOHCAHTOA, it is only TOA that has opposite and adjacent. So we know that Tua says that the tan of the acute angle, so the acute angle here is 70 degrees, is equal to the length of the opposite. So the length of the opposite, that is the height of the mast. I'm naming it as line TG. So opposite over adjacent. Adjacent is D. Adjacent is D. And then for D to 4 decimal places, we had 18.8073. So tan 70 is the same as tan 70 on 1. When you cross multiply, we have 18.8073 multiplied by tan 70. So tan 70. And this must be equal to 1 multiplied by line TG. That gives line TG. So let's see. 18.8073 tan 70. So we have 51.6726. 51.6726. So that is the height of the telecommunication mast. So that is for BI. So remember, we were supposed to calculate and correct our answer to the nearest whole number. So when you correct to the nearest whole number, you see that the height of the mast is, so to the nearest whole number, we have 52 meters. So that is for 9BI. BII, we have to calculate correct to the nearest whole number the length of line HG. So line HG from H to G. So let's join the 2 points to get the required line. So we are looking for the length of line HG. That is the line in red. So how do we do that? So to be able to calculate for the length of HG, we need to create a right angle triangle. So how do we create a right angle triangle from line HG? So we could see that we can, when we join point H to this particular point, we will surely get a right angle triangle. So this green line, once we join point H to this particular point, we see that we are getting a right angle triangle with a red line. So this point or this line here will meet the green line at right angle. So we now have our right angle triangle. So let's name this point here as I. So because it is a right angle triangle, it will surely have 3 vertices. So G, H, and then I. That is a right angle triangle. So there is certain things that we need to know, especially with the dimensions of the right angle triangle. So if line SH measures 10 meters, then it means that line TI will also measure 10 meters. So we'll also measure 10 meters. And from the previous calculation that we did, we knew that the height of the mast, or we saw that the height of the mast was 51.6726 meters. That is to 4 decimal places. So if TI is measuring 10 meters, Then what will be the height of IG? So you are going to subtract 10 meters from 51.6726 meters. And when we do that, that will give us 41.6726 meters. So that is the height of line IG. Now what will be the length of IH? So we saw that from T to O measure D, then from O to S also measure D. So the full length of line TS will be D plus D. So let's find out. 18.8073 is either we multiply by 2 or we add to itself. So plus the same thing, 18.8073. So we have 37.6146. 37.6146. Let me write it here. 37.6146 meters. So that is for line IH. Once we know two dimensions of the right angle triangle, you can simply apply Pythagoras theorem to calculate the remaining side. So from Pythagoras theorem, remember we are referring from triangle HIG. HIG. We know that the squared of the longest side, that is the length of line HG, should be equal to the sum of the squares of the other two sides. So line IG squared plus the length of IH squared. IH squared. So we just do our substitution. So we have H G squared being equal to, what is the length of IG? So IG, we had 41.6726 squared plus IH squared. So IH2 we had 37.6146 all squared. So let's see. HG all squared. So we are going to enter everything once on the calculator. So we have 41.6726 all squared plus 37.6146 all squared. So 3151.4637. But remember, we are looking for hg, not ag squared. 3151.4637. So what do? We take the square root on both sides. Square root on both sides. So the square root and the square will cancel out, leaving hg. On the left, let's see, square root of 315. Sorry, square root of 3151.4637. 56.1379. 56.1379. 1379. So hg. Remember, we are also asked to correct the nearest whole number. So to the nearest whole number, we still have 56 meters. So that is for question B, I.